Hello friends, welcome to my channel. Let's have a look at problem 2570. Merge two 2D arrays by summing values. So actually before this problem we have revisited problem 21 as a warm-up. So if you have time, it's good to check out that video. So here in this video we're going to share a solution based on the two-point trick. First I'll read through the problem statement. And in between, I'm going to emphasize one assumption. Actually, the assumption is this one. So this assumption actually greatly simplifies the problem. And then after we read through the problem, we're going to do the analysis based on the current assumption. And then after we solve this current problem, we're going to drop this assumption and write a solution without this assumption and solving a more general problem. So with that said, let's first look at the problem statement. So here we are given two 2D integer arrays called nums1 and nums2. So the elements in these two 2D arrays has such a form. Actually, it contains a ID and a value. So the assumption here that we're going to comment further is that so each array contains unique IDs and is sorted in ascending order by ID. So our task is to merge the two arrays into one array that is sorted in ascending order by ID, respecting the following two conditions. So first, only IDs that appear in at least one of the two arrays should be included in the resulting array. So this is the one. And the second one is very important. So each ID should be included only once, and its value should be the sum of the values of this ID in the two arrays. If the ID does not exist in one of the two arrays, then its value in that array is considered to be 0. Actually, this one I don't think it's quite necessary if we have the first half of the sentence. So here again, the key is that each array contains unique IDs. So for example, if I have a key which appears in both the two 2D arrays, so each appears at most once in the two arrays respectively. So this assumption actually makes the solving of this solution very easy, I would say, or very straightforward. So here, what we want to return is the resulting array. So the returned array must be sorted in ascending order by ID, right? So with that said, so we can look at one example. So in example 1, so this is nums1 and this is nums2. So in nums1, so you see we have the keys that are 1, 2, 4, and in nums2 the keys are 1, 3, 4. In each of the two arrays, the keys are unique, right? But the key 1 appears in both two arrays in example 1. So in this case, so the return for key 1, so we have 2 and we have 4 here, so it has 1, 6. Then we have 2, that is this value 3, and the 3 value 2, and the 4 it also appears in both the two arrays. So the sum is 5 plus 1, that is 6. So this is example 1. So similarly, we can interpret the output or return for example 2. So here the additional assumptions are the following. First, the length of the two 2D arrays are bounded above by 200. So this 200 actually is not a very large number. Secondly, so each element in the two 2D arrays have length 2. So that's just an follows the above statement or just a consistency. So the ID and the values are in between 1 and 1000. So both arrays contain unique IDs. So this is actually very important. So this is the same essentially as this half here. And then both arrays are in strictly ascending order. So this 2 bullet points basically is this assumption. So with that said, we are ready to do the analysis. So actually, I should admit that at the very beginning, I was actually solving a much harder problem than this problem itself, because I didn't I sort of misunderstood or misinterpret this this assumption. So with that comment done, let's look at the treatment. So here we are going to use two-pointer trick, or just C. Let's see, this is the C, a for loop. So here the prototype problem is like problem 21, or more generally, in a more simplified version. So for two sorted lists, so we combine them to a sorted list. So this prototype problem is very standard. So we start from the beginnings of the two lists respectively, and then we compare the two values, and we put the smaller value to the result, and then move to the right in the corresponding list. So afterwards, we just add the remaining elements in the long list. So for example, here we have list 1 and list 2, right? And then the result will be 1 and 2, 3, 3, and 5, right? So this is actually the typical way of solving this problem. But here we have 2D arrays. So if the keys in the two lists are the same, so we are going to add them. But if we only due to the assumption, so we only add at most once. So this is the item 3. So for the current problem, the keys play the elements role in the prototype problem. But we just need to add the values if the two keys from the two lists are equal. So actually, it's an assumption that each array contains unique IDs and is sorted in ascending order by the ID. So especially the first half of the sentence here, unique IDs. So this actually makes the problem easy. So these assumptions lead to that we need at most some vars only when two keys from the two lists respectively are the same. So here is an extension. So in the current problem, we have this assumption. So we have the unique keys assumption or unique IDs assumption. So in other words, there are no repeated keys in each list. For example, here is an example 1, right? So we have the keys are 1, 2, 4. But what if there are repeated keys in either or both of the two lists? For example, so we have 1, 2, 2, 3, and 2, 88, 2, 999, 4, 5, so to speak. So if we still want to do the merge and sum as in this problem, and then the problem is slightly harder. So we are also going to provide a code format in solving this more general problem. And then for sure the code will also solve this specific one because it's a special case. So with that said, I guess basically we understand the overall plan for this video. First, we solve this problem using two-pointer method with the assumption here, the unique case. And then we actually drop this unique case and give a solution. So this solution will solve in particular the problem here and solve actually a more general problem. So with that said, let's look at the coding. So here I'm going to use two pointers, right? Two-pointer method with the unique key, unique ID assumption. This would be actually very straightforward. So here first I'm going to track the length of the two 2D arrays, so nums1 and nums2. This is just some preparation, so we are going to have a result. So this result we are going to hold the list, the pairs, so that is the IDs and the values. So here let's call it preparation step. And next, so we're going to run the two-pointer procedure. So this is actually very standard. So here I'm going to initialize the two pointers to be at the very beginning, that is I and j are both 0. And then we're going to do a while loop. So while I less than m or j less than n. So here, for this kind of problem, we can actually use and or, but once we determine a logical relation, and then the coding below, it will be slightly different. We need to treat the addition case, but in this case, we use an or. In other words, we consider the different length case inside this while block. So first, let's consider here. if I equals m, in other words, we run out of the first 2D array, nums1, and then we just need to append the current element in nums2. So sorry, here we need to write 2. So we will get nums2 g, right? And then we're going to move forward g by 1. So this is one case. Another case is that j equals n. In other words, we run out of the second 2D array. So in this case, we're going to append nums1 I, and then we move right I by 1. So this is the case. Another case, both the two actually are not empty. And in this case, we should compare the key, right? First, if nums1 I 0, so this is the ID, right? Equals nums2 g 0. So if the two IDs are the same, so what we're going to do actually is this. So we append the ID. So we can use either of the two because they are the same. So nums1, say I 0. And then we need to do the sum for the values in the two length 2 array. So that is nums1 I 1 plus nums2 g 1. So with that said, so we finish the current key. Then we move I to the right by 1 and j to the right by 1. So actually we'll see simultaneously if we interpret, but in code, so we have order here, right? So this is the one case. Another case is that nums I 0. So actually we can copy the line and then change the mathematical relation symbol. So if this one, let's see, nums2 g 0. So in this case, the first key is or ID is smaller. So in this case, we're going to append nums1 I, right? And then we move I to the right by 1. So else, so in the else will correspond to nums1 I 0. The key is actually larger than the one in the second 2D array. So in this case, we are going to append nums2 g, right? And then we're going to increment g by 1. So this is the full logic. So then the third step will be do the return. So in this case, I'm going to return the result. So this actually forms a solution to this problem. Let's first do a check. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the cases. So with that done, now we are in a position to comment on the assumptions. So here, so when we do the assumption, so we see that each array contains unique IDs. So this is actually the very assumption that simplifies the problem or the coding. So what if we do not have this assumption? In other words, the arrays can contain unique IDs. And then we still want to return do the merge, but in the merge we will have unique IDs, and the value should be the sum of values in each of the two arrays, or in the all of the two arrays. So in other words, so for example, we have this case. Let's write an example here. So we have 1, 2, and 1, 3, or 1, 3. So in the second one, we also have a 1, 5. So in the result, what we want actually is 2 plus 3 plus 5. 2 plus 3 plus 5, right? That is 1, 10. So that's our thought. So here, due to time, actually I want to change this version to be v1, and then we actually put the code here. So I'm going to comment out here. So let me change this here, move it to up. So here I'm going to call this one a solution. So in this this form of coding, so actually I assumed at the very beginning, or I misunderstood, so I didn't take this assumption into consideration. Therefore, we solve a more general problem. So here, let me explain the logic. So here we initialize a result variable, and then we get the length of the two lists, and then we're using the true pointer method from the very beginning. But here I'm using add just to do it in a verbose way. And then we get the IDs and values in the true list, and then we want to compare the current value and the current ID. So if ID 1 is smaller, so I'm going to call the current ID and the current value to be the ID 1 and value 1. And then we want to move sliding windows in the first list, so that I can add all the values for corresponding to the same key. So if not, so I'm going to break and then reset this I, right? So this is the one case. So similarly, if the ID 1 will be larger than ID 2, so we do the same thing, but with sliding window in the second list, so that we add all the values corresponding to the same key, and then we break and reset G. So then we just append the corresponding pair, I would say. And so this corresponds to the case. So this is smaller and this is smaller. And then the equal case, right? So the equal case, we need to collect all the values in the possible values in the true list. So here we set this one to be the value 1 plus value 2, and then we sliding window for the first 2D array, and then we do the same thing for the second 2D array. So afterwards, we're going to check if the shorter one is run out, so we need to add the remaining one. So here is the one case. So if the first list is longer, so we need to add the corresponding result corresponding to this case. So still we need to sliding window, because in this case we assume that the first the list can have repeated case, but though in a sorted order. So here we do the same thing, and then we sliding window, and then we reset, and then we add the result. So similarly, if the second one is longer, and then we're going to, or more precisely, the second one is still there after the first one is run out, and then so we would consider doing sliding window for the second one. So we do the sliding window and reset G, when we add the result, and finally we do the return. So this is another solution format. Here it's a little bit long. The reason is that we do it in a very brute force way to explain the idea. And so here these two blocks. So here I'm using add just to make it more straightforward. And actually after that, so we do this two while blocks. So only one of the blocks will be entered. So if the first one contains more unique IDs, so this finally we will enter this while block. If the second 2D array contains more unique IDs, so we're going to enter this while block rather than this one. So finally we do the return. So this is another solution for sure to this problem, but actually this second format solves more general problem. So with that said, I guess let's first do a check. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it solves the generic case. So here I guess it's maybe better to do another test. So here I attach another 2 to see if it still passes, right? Or it will give us an invalid test case. The reason is that in this case the unique ID assumption, but you can test this code. So let's delete this part. So the test again. Yeah, I guess with that said, we provided actually two solution formats to this problem. So first one, solving the problem exactly with the current assumptions. And the second version actually solves a slightly general problem. So I would say for this problem, the prototype is still merging two sorted lists. The list can be a vanilla list or can be a linked list, but here it's just adding some complexity by considering the IDs and values. So with that said, I guess that's about it for this video. Thank you.